You can give this a shot, but if you get stuck, we'll just go through it together. So this was the part that was confusing us. Maybe let's go through it together. So let me show you the points here. So let's step away from this problem for a second. All right, here I have a doll. Now, is this doll right side up or upside down?
Right side up.
All right, and now let's say that we're going to get an inverted image. If we're going to get an inverted image, draw what the doll would look like. Draw what the image would look like.
So it just says flip like this.
Mm-hmm.
So.
Now when things are, here's our principal axis. When something is inverted, that doesn't mean that it's inverted horizontally. It's inverted vertically. It's inverted around the axis. When we say that an image is inverted, we mean it's inverted around the axis. And we usually draw the axis horizontally. So it usually means that we are inverting vertically around that axis. So
I guess what's confusing me is there's a lot of times, like in lab, we were doing something where we were projecting a letter F onto a screen, and a lot of times, like the F, like it could be either like this, or then sometimes it would be like upside down. So like sometimes it'd be like this.
Let's see. Well,
but I think we still call that upright.
I mean, if you lay the letter F like this, then the inverted letter F would look like this. And if you lay the letter F like this, then the inverted letter F would look like this. So depending on which way you orient the object, you can get all kinds of different types of flips over here. But the key point is, when we say that an image is inverted, we mean that it's inverted around the principal axis. When we say that an image is inverted, we mean that it's inverting around the principal axis. What we mean is it's got a different orientation with the principal axis compared to the object. Instead of calling these inverted and upright, we might want to call them inverted orientation and upright orientation, or even opposite orientation and same orientation. In fact, I'm kind of thinking maybe next time I TA this, I'm not going to use inverted and upright. I might use opposite orientation and same orientation, except then I'm going to lose my infrared and ultraviolet memory aid, but I might have to bite the bullet on that, and we'll see why in a second. Okay, so this has the opposite orientation to this over here. By the way, you would probably call this right side up. And we would probably call this image upside down, right? Now, we're not calling it upside down because it's opposite to the object. We're calling it upside down because we normally think of a doll's head should be on top. It's just upside down compared to the way you usually orient a doll. Okay. All right, now I have another doll object. Now, is this doll object right side up or upside down? Just because this is not normally the way you would orient a doll. So this is upside down. Now let's say that we're still going to get an inverted image. We'll draw what the inverted image would look like. Okay, good. Now there's an important lesson there. Here's the inverted image. The important lesson is this upside down or right side up? When we say it's right side up, we mean it's just oriented the way the dolls are usually oriented, with the head on top. The important lesson here is inverted does not mean upside down. Inverted does not mean upside down. It just means opposite orientation to however the object started. When we say that an image is inverted, we just mean that it's inverted relative to the object.
Oh, so the flowers in the question would have had to start upside down.
There you go. Okay, that's right. That's the point. So the thing that was confusing here was that he said that he wanted the flowers to look right side up, and you were saying, you were thinking that right side up means upright, but it doesn't. Upright just means same orientation as the object. So if the object started upside down, then an upright image would still be upside down. Again, this term upright is very confusing because upright sounds like right side up. It would be better to really call this same orientation as object, and inverted is really opposite orientation as object. I guess I'll have to think of a new memory aid there instead of the infrared and the ultraviolet. Okay. So what was the answer to part B?
So what did it ask? Are the actual flowers right side up or upside down? Upside down.
Yeah. Because because we know that we're in this region of the chart, and we know that in this region of the chart we always get an inverted image. So if we want our image to be with the head on top, we need to draw it with the head on the bottom. Okay, good.
Should we go on?
Yeah.
Are the actual flowers placed above or below the central axis of the mirror? So below.
And why is that?
Because that's how they're upside down.
Not necessarily. They could look like this. Here's a doll that's upside down, but it's still above the central axis. You can still be upside down and still be above the central axis.
And that is what you would get there. You would get a right side up and below the central axis.
Is this what you're thinking?
Or beneath it. Because it has to be on the same side.
Do they? So remember, we're getting an inverted image. And inverted means that you're reflecting around the central axis. So this is the correct picture. This is the correct picture. Remember that when we drew inverted before, it always looked like this. Anytime we drew something inverted, we always had one arrow pointing up from the axis and one arrow pointing down from the axis.
What I'm saying is,
yeah.
So we said that the image is going to be on the same side as the object.
Oh yeah, I haven't even been worrying about that, but yeah, I've just been doing this. But yeah, we should have. In fact, the image is going to be pretty much in the same exact place as the object.
It would be below the axis.
Yeah.
Upside, right side up.
So if we put the object here. So all those last examples I was doing were not about this particular case. I was doing examples with a real image, basically. I was just doing a general percentage of a real. Oh, no. So there we go. So we want a real image, right?
Yeah.
So which side of the oh, but I was doing a lens, and we're doing a mirror. Okay. So we have here our mirror. Yeah. So which side is the image going to be on for the mirror? If it's real, it's going to be over here. Okay, so yeah, so if you put the object here, we know it's going to be inverted. It's going to be inverted around the principal axis. So with this mirror, if you put the object here, you would get this image. Well, is this right? Is this what we wanted?
Well, you want it to be above the central axis of the mirror.
So is this right?
No.
No. So because here the image is below the central axis. So let's try changing that. Where should we put the object?
So you want object. So you want to put the object upside down below the axis.
Go ahead and draw that in.
So you want to put it.
Good. Is that the object or the image that you just drew?
Object.
Good. That's right.
So you have the image right above it.
Go ahead and draw your image. Yeah. How do we know this is going to be the image? Because we're at this point, which gives us an inverted image, which means that the image is reflected around the principal axis from the object. So if the object is like this, the image is like this. And this is what we wanted because they asked us for it to have the flowers above the stems. That would be right side up. I'm drawing the doll because I can't draw flowers very well, but it's the same idea. Then that would give us this. Okay, so you can see that he's not just going to give you plug and chug questions on the exam where you just plug into the lens mirror equation. What he's really doing here is, when we talked about this before, we didn't quite really explain exactly what inverted and upright meant, you can see now. So you can see what it really means is inverted means that the image is flipped around the principal axis. Now inverted does not mean upside down, right? Because here, if the object starts upside down, then the image ends up right side up. And we also didn't talk about how it also matters where you're placed relative to the principal axis there. So, okay, well, obviously this is a good question to go back and redo because you're sure to see something on these lines on the test, just a variation. So this is definitely a high payoff use of your time there. Okay. Any questions about that?
No.
No? Okay.